All right, good morning. Thanks for joining us on such an early event here. I'm sure that we're still missing a few from the 4K and 8K that's taken place, so maybe we'll get a few more that will trickle in here soon. My name is Matt Carter. I'm a solutions architect for AWS Elemental, and I'll be co-presenting with a couple of folks here, one Kate Whirling from our NatSec team and Worldwide Public Sector, and we have a special guest, which I'll introduce here in just a second. If you're not familiar with AWS Elemental, we're the video overlay services for AWS. And so we're going to be talking today a little bit about video streaming technologies combined with machine learning, and a little bit through the lens of government workflows for U.S. government. So this could be public safety, federal, law enforcement, and whatnot. And this wouldn't be a proper military or government communication if we didn't have a list of acronyms. Typically, at the beginning of one of these, there's either a slide that says this slide was intentionally left blank, or a list of key acronyms. So I thought I'd choose the acronyms because you may not be familiar with these. Full motion video, think of that as compressed transport stream. Okay, MPEG-2 transport stream, typically carrying video traffic. A lot of times there's a component of geospatial with that. ISR, intelligence, surveillance, reconnaissance. I'll be using this one a little bit throughout the deck. And this is a bit of a market kind of segment within the government that kind of defines a very specific area of focus. PED is process exploitation dissemination. Think of that as the workflow. So once video kind of comes into the organization, we do something called a PED process. You'll hear that kind of being thrown around a little bit. So just want to make everybody comfortable with the terminology, and then the rest of it should be pretty much general commercial off-the-shelf terminology. The agenda for today, why full motion video is so critical to the government. You know, it's critical to us as viewers and consumers, and the government depends on that in a lot of cases too for intelligence gathering. Machine learning speaks for itself. It's kind of a hot topic right now. And applying machine learning to video, those two things go hand in hand really nicely, and Kate's going to talk to us about that. Learnings from Enterprise Challenge 2018, our guest speaker will be discussing that. And if you're not familiar with that venue, that is a USDI Undersecretary of Defense for Intelligence funded activity and led by the National Geospatial Intelligence Agency. And so we actually participated in that this past year and had some great successes that we're going to share with you. And when I get to John here, we'll have him go a little deeper into that. And Motion Imagery 2.0. Motion imagery defines a larger group of any type of video or imagery that could be running as little as 1 hertz per second up to 30 or 60 frames per second. And full motion video kind of a narrower subset of that falls inside of motion imagery. So this concept of Motion Imagery 2.0, we're going to be discussing the introduction of streaming-based technologies and kind of beyond the legacy transport, stream, and broadcast type of traffic. I thought it would be fun that maybe to put us all into the same frame of mind as how the government organizations may use full motion video traffic from selecting one of my favorite here from a series called Jack Ryan from Amazon Prime Video, if you're not familiar with it. It's a lot of fun. If you haven't had a chance, please encourage you to go to your Prime accounts and take a look at it. But you'll see here in this clip, it's about 1.5 minutes of an intelligence agency that basically is connected to a forward deployed situation that's unraveling. And the video that's coming through from an aerial perspective acts as the conduit for information. So we're pulling information from a forward deployed location and bringing that back into a centralized command and control. So let's have a look, and then we'll talk about it a little bit more. And what this really portrays is that the Hollywood industry really isn't too far off from reality, that they're pushing this video content from a tactical environment to an intelligence command center and making real-time actionable decisions against that. And so we're going to try to help them with that kind of capability by invoking some newer technologies with our cloud services called media services, and we're going to touch on that in just a sec. Before we do, as we came out of Enterprise Challenge, the Motion GeoInt community basically had this to say about the test that we conducted. Cloud-enabled streaming technologies will, in fact, transform full motion video. And this was a collective kind of agreement amongst the community and the Motion Imagery Standards Board and other organizations that participated. And so we see a lot of evolvement of this kind of video traffic moving beyond broadcast and into this over-the-top streaming delivery system. So what's today's ISR and PED systems look like? Well, they exist globally. They're distributed, all over the place. They support our U.S. forces as well as our coalition partners. So you have folks like NATO. Combined of air-ground systems. So we have some of the most state-of-the-art aerospace technologies being deployed with these. They offer a sophisticated multi-int capability, multi-intelligence gathering, so really talking about fusion of different types of data. Mission-critical workflows. This one is a key point. This truly is mission-critical in a lot of cases and sometimes life-dependent. And it must operate in a 24/7 real-time operational environment. So they don't check out at 5 o'clock. There's things that are being monitored and looked at around the world constantly. And this is kind of what it looks like, from our perspective of what does a ISR system look like? Well, you have intelligence gathering over here on the left, and you're moving that through a complex network, a lot of times global, into an intelligence processing center and trying to make sense of that information. But sometimes moving that data is a bit challenging. That's what we've seen in the past, and this is where our folks at NGA are exploring some of these newer technologies to make things a little bit more efficient. So video is, in fact, everywhere. It's not just stateside, but it's deployed at the tactical edge. You have sensors over here to the left of that diagram. You also have consumption that's occurring there. But we're moving it glass to glass. So this concept of taking imagery in from a camera sensor and getting it out here to the ISR and PED analysts. And this could be, again, in a global environment or deployed forward in just a tactical arena. So let's look at this. This is probably a little bit more familiar for most of us. This is a depiction of our Amazon Prime Video services. And for us, we're used to that as consumers of taking content on our mobile devices, tablets, large screen displays. And the beauty of this technology is it's streaming, right? We've all heard this notion of streaming, and that is formatted specifically for that device type. And this is where we introduce this concept of adaptive bitrate streaming. We believe that the same technologies can be utilized in an environment that could be tactical or mission-related and disseminating the same content for our intelligence communities as well as Department of Defense. So some challenges and solutions. Well, we know that we have to deal with a global reach with a lot of on-premises equipment today. And so what we'd like to do is augment that with some cloud-based technology. So you've got things like storage and compute, now video services. Highly managed compute, storage, and network infrastructure is very intensive. If you can imagine data centers being placed all over the place, there's a lot of time that goes into managing that. So we can complement that with managed services that really kind of take the administration time down. Commercial technologies offer a best-in-breed, best effort broadcast and multicast delivery format. We don't really like the term best effort, although that's been utilized for decades when we're talking about UDP-based technology. Adopting now to the streaming side, we're moving from UDP to the TCP stack, so it's a lot more reliable. Complicated and outdated applications supporting the PED process, so there's been a massive investment of various vendors building applications that support this workflow. So we don't want to just forklift and remove that. Instead, what we want to do is leverage, off-the-shelf commercial available machine learning technologies to augment the analyst process. So this brings me to Enterprise Challenge and our proving grounds. If you're not familiar with this exercise, again, this is a USDI-funded and NGA-led event. We participated this year and have been part of that for a little while. And looking forward to doing some things next year, in fact. But the number one goal of this Enterprise Challenge was that top line, proving out the feasibility of live full motion video in the cloud. And it's a lot easier to produce or curate or generate content in a file-based structure, but when you start doing that live, it is actually quite complicated. We've taken that complexity down by introducing these new media services that we're going to talk about. AWS Elemental had also demonstrated the use of HEVC, or H.265. So if you can imagine an aircraft that was flying and connected to a ground station at 3 megabits per second, and an AVC H.264 encoder was operating at that same 3 megabits per second. Now introducing HEVC offered a 50% bandwidth improvement to that image quality without increasing the bit rate. So that's fabulous. It really helps out things like machine learning. So let's take a look at this from an architectural perspective. We're going to talk about 2 workflows that we actually conducted, maybe 2.5 or 3. But this first one, let's set it up. We've got Bogue Field, North Carolina on the left. So that's where we were flying out of. We were then transmitting that data through the cloud. We used US East, Northern Virginia. And then over in Herndon, we had some analyst tools where we would able to see this video traffic and kind of analyze it and understand kind of the parameters of how it was operating. So in this first workflow, all we did is we simply took the multicast video or unicast video, reflected it into the cloud, and from the cloud, connected it to Herndon, Virginia. And so we're just basically using the AWS backbone to transmit this live video from a best effort UDP model and bringing it down to what's called GFE, Government Furnished Equipment, PED tools. And our latency there was surprisingly only 1 second. That's pretty good for just basically conduits for stretching a wire from North Carolina to Virginia. But we didn't want to stop there because that was the best effort approach, right? So that's unicast. That's a one format or one profile. Is what we wanted to do is take that beyond into this new adaptive bitrate world. So if we follow the same feed inside the cloud, coming out of that EC2 instance, which was a unicast, we interface that to AWS Elemental's Media Live service. And this is a transcoding in the cloud capability, offers live transcoding, does adaptive bitrate, so I can bring that one channel of 3 megabits per second in and create a nice bouquet of 3 megabits and 2 megabits and 1 megabit. And so I have now different resolutions for I can support different device types. I interface that to Media Package, which provides on-demand packaging for my content. So if I'm delivering it to a laptop or an iOS-enabled device or an Android device, it's going to have the right wrapper in order to be consumed. We interface it with Amazon CloudFront, CDN technology. So now we've become a global distribution and can get this content served out to web clients. And that's another big difference. Moving through the model of the adaptive bitrate, we go from a legacy thick client application to now web streaming and using just our browser in order to pick up this feed. We had an EC2 instance here at the bottom right, which was kind of like a little portal viewer from one of our Amazon AWS partners that joined us in this exercise known as Crafter. And they had API calls into each of these services. You see the little dashed line. And so they were able to present this really nice web UI in leveraging the power of all these services behind them. So things that were already available, making that available to them just through a simple API call. And we took it one final step further and said, hey, while we've got this traffic coming in, let's just do the typical off-the-shelf machine learning in AI and see what we can produce from that. And what we found is we were really easily able to just generate automatic tags. So things like car or truck or boat. They were simple. You know, this was a first attempt, but it worked really well. And so we were able to provide searchable, contextual information back to that video content without a human in the loop. And so now this brings me to the National Geospatial Intelligence Agency, and it gives me great pleasure to introduce a good time colleague of mine, Mr. John Bordner from the NGA. So please welcome him to the stage.
Hey, thanks, Matt. I warmed that seat up for you. So And Matt, you've been great to work with, and we actually met out in the National Association of Broadcasters, what, 10 years ago, something like that. So Matt has already talked about the Enterprise Challenge series of events. I will point out yet again, it is USDI sponsored. Secretary of Defense for Intelligence, that includes all of the military services, the agencies, Five Eye partners as well, so that's the US, Canada, Australia, New Zealand, UK, that's 5. Huge venue. I'm going to jump off of this slide, but not until I point out that last bullet, which is my favorite. It is okay to fail. And in fact, we celebrate failure. Remember, this is a test and evaluation. We're trying out new stuff. We want to break it there before it starts going out to the field, right? Do it in a safe environment that is indicative of what's out in the real world. Break it there, fix it, do a fast turn. So we throw the event, NGA throws the party, so to speak, but we like to participate in the party once in a while. Slide, please. Thanks, Alexa.
You want this sucker?
No, I don't. So last year, and this came from our longtime Noah and Matt and your team now at AWS Elemental, and Matt came to us about a year ago, because it was a year ago that AWS Elemental, in fact it was here, announced this media services. And he told us about it, and we're going, well, wait, you can do video management, glass to glass, all in the cloud. Well, we were given direction by the director of NGA to move all of our services, all of our capabilities to the cloud, and here it is already as a commercial solution. There's a lot of similarities between the commercial world and how we do video, but there's some distinct differences. So we set up this architecture like you talked about. We had an airplane all the way down from glass of the camera lens to the glass of the computer screen or your iPhone or whatever. And we wanted to test video quality. We wanted to test latency. We wanted to make sure that it still supported the analysts. And we wanted a first look into what it means to put video in an AI framework and then operate machine learning models against it. That was a stretch objective. So we don't mind failing, but we're not stupid about it, so we had some de-risking spirals, and boom, there we are, MainX. We did it May of this year. Slide, Vanna. Coming up with a different name for you on every... So here's what we had. Had an airplane, real live airplane, Cessna Skymaster. We had a cinematic quality camera mounted on that baby. We had to get it down to the ground, so we used a mesh network because it was free, and free's good. So we teamed up with the Coast Guard to do that, and that was very fortuitous, actually, and we'll get to that later. And that's what got it down to the ground. You see the ground station, the HQ that Matt talked about down in Herndon. That's where we kind of managed all of the video workflow. That's where we had our video test expert from the commercial market. We even hosted we called it an open house. It wasn't a VIP day because we served cookies and coffee, so it was an open house. And then we had the EC18 consumers. Remember, this was on the commercial internet. All of our partners participating in Enterprise Challenge could pick up their phone, get on their laptop, desk, computer, whatever, and be able to dial in and see the live video we were shooting. Kind of cool. And get their feedback. Side. So this is the video architecture that Matt talked about, but the actual, this is the same old logos and everything. They're changing their logos more often than NGA redoes their, so I'm not going to go into this. We did 4 different workflows, and it was beautiful. We learned a lot of lessons, and here's just kind of a quick finding, if I can. Top strategic level, I always hated this. Crawl, walk, run. Be cautious, be careful. Crawl first, then walk, then run. This is a commercial application. It is out in the real world, earning money, earning revenue. Let's throw it out there, run with it, play with it, break it, be that 2-year-old toddler running, fall on your face, get up, try it again, fix what you broke, and do it again. And you can do that when you're talking about a proven commercial capability that fits your needs. And then we wanted to make sure that we didn't break what we're doing now, right? Is that the Hippocratic Oath? At first, do no damage. And we did not do damage. Video quality, latency was the same as the way we're doing it now. But why stop there, right? Because we went into the cloud. Allows you to do a lot of other really neat things. And then you're going to see those down at the bottom. You got the standard stuff, you know, agility, scalability, resiliency, something that I call controllability as well. You go around to the building over at the agency and you ask somebody, describe to me the end-to-end architecture. You don't know. It's very pipelined. You've got the Air Force doing their thing and they're feeding. The Navy over here is coming over to there. You're transcoding multiple times. You're saving it in different locations. It is difficult, Byzantine at best. But we controlled the entire workflow from a single laptop. And that control means you can build out an elegant, simple, and efficient video workflow. And when you do that, you increase efficiencies and you effectively increase your quality, maintain quality and reduce latency. So one of the first lessons learned was being able to control. ABR, the adaptive bit rate, I mean, it takes into account what your capabilities are on the particular device. I'm going like this because I don't have my phone up here, but when you use ABR to stream to you, it knows you're trying to view it on a phone. It's not going to push you some huge, 4K whatever that's going on your phone. If you don't have the bandwidth, it's going to give you only the bandwidth that you can handle. Adaptive bit rate, tailor-made for that leading edge, the people that don't have the comm pipes, really. The second to last one, you're going, John, of course, storage direct to the cloud. That's obvious, right? We're doing this all in the cloud. You're an idiot, John. Well, you know what? Stop and think about it. We got the video in the cloud. You save it. That's where all of your other data is. That's where you're running the machine learning and all the other algorithms. Big data, that's where all the other agencies are storing data. Now you can get down to business. And then we also showed hosting analyst workstations in the cloud to be able to use virtually. We gave an analyst full capability on a tablet device. Slide. So we learned a lot of stuff, and actually we learned what we didn't know and what we needed to explore. Explore a little bit farther. So this is what we're doing. We're running, right? We told you we're going to run. We're kind of flight following the movement of these media services to the C2S, SC2S, and GovCloud, and Matt gets a call from me, probably weekly at least, going, hey, where are we on that timeline? Because we're anxious to see it. We have NGA, Motion GeoInt Services. Some of those brilliant people are in here. They're the big brains, 8th floor at NGA, that are putting together the future video architecture for NGA, for all of the services and agencies. So we're doing more than flight following. We're engaged with them. The Air Force makes me proud to be an Air Force veteran. They took exactly what we did during Velo, and they're testing it out in a pilot to operationalize it. And as those services get put on C2S, they're going to be throwing in live feeds from in-theater following Air Force workflows based on what we did in Velo. And the cool thing is the Air Force is talking to the MGS people so we can build out that elegant video architecture end to end. It's what happens when you get the services and the agencies working together. First time I've seen it, and I'm damn proud of our Air Force, Navy, Army's coming on board, and of course the smart guys and gals up in the 8th floor of NGA. Another thing we're doing is putting metadata into ABR. That's one of the downfalls of ABR, adaptive bitrate that Matt talked about. There's no metadata. And if you're a video scientist, if you're an analyst, that breaks your heart because you don't know where it was taken, you don't know when it was taken, you don't know where it was taken from. It is situational awareness purposes only, really. Well, we got the MISB, the Motion Imagery Standards Board, also owned by NGA. They're equally brilliant people, but on the 7th floor, working with AWS Elemental engineers who authored and presented a proposal for putting ABR, or putting metadata into ABR. Go home and think about that. This is probably one of the most important points on this slide. Think about what that will enable you to do. Now it's not just pixels. You've got coordinates, you've got time, you've got all the search, discovery, and retrieve capabilities. When you use that video, you know what it's taken from and any kind of tagging you want to do on it, all encapsulated, tied to that video. Huge win. And then we're also looking at CDS as a cross-domain solution. We're going to be using it in the next phase to push ABR cross-domain. All right, so this is what we're doing this summer. We got an airplane here. We're going to have HD camera. It's going to be a camera ball assembly. Same thing that's in the Reaper these days. And we're going to have 2 Snowball Edge storage and compute nodes. That is an availability zone. That is a data collector. Coast Guard, great teaming partner. They've got some super scenarios we're going to be running. They have a video capability, and look at that, another storage and compute node. Down on the boat, that's going to be a fast boat, doing a bunch of cool Coast Guard scenarios. These are our users. We're also going to put a Snowball Edge on there. It's not on the slide because I built these slides before we decided that. So check that out. 1, 2, 3 nodes. And then down here at our little headquarters, we'll call that the FOB, the Forward Operating Base, we're going to have 2 Snowball Edge devices on there. You got 4 availability zones providing data to these people. They're getting the video, they're getting the ELINT, they're going to have a map service, they're going to have analyst capabilities. I'm not crossing this line. They're going to have the machine learning models that Kate and her gang are putting together. All of this to the people that need it most, right? All of this self-contained. So there you go, slide. Got to have an elevator speech. And if you're only going up 1 floor with a general, better be a short one, right? That's it, right there. Everybody read along with me, or just move your lips, humor me. Create a small, impromptu sensing and sense-making cloud for the tactical user in harm's way. That's what we're doing. We call it microburst. It's a military or a mini intelligence cloud for battlefield urgent reconnaissance and support to targeting. Descriptive, that's what we're doing. Slide. Everything I said is much more eloquently written down there. Take a picture, and you can share it. Hit the other slide. So these are our goals. Almost like Velo, we're going to test it. We're going to test the snot out of it. We're going to test the quality, the latency. I want to test a failure because we like breaking stuff. And we want to test it subjectively with real scenarios generated by the Coast Guard. We have 3 workflows, a hybrid that uses a classic unicast UDP to move the video around, but using ABR to distribute. We're going to do an all ABR. We've got 5 different analyst tools that are designing to that new standard that we're proposing. So it's going to be an all ABR workflow. And then we have one ABR with a cross-domain solution thrown in there. What's powering that? When we're going forward in May, It's going to be the AWS media services that are the backbone behind that, driven by the new Snowball edges, the storage and compute, and the machine learning language, or the machine learning algorithms and models that are designed by you, Kate, and your team. Now, I got the distinct pleasure of introducing Kate. Now, Kate actually is an alumnus, whoever. They never taught Latin. We both graduated from the Air Force Academy, separated by 3 decades, I think, and probably 2 full points on our GPAs. You probably got a 4.0. I graduated, went on to study, I don't know what, as a graduate level wizardry, data wizardry. So, hands together. Kate, tell them how it's done.
Thank you. All right, cool, no pressure. All right, so hi, my name is Kate Worling. I'm a solutions architect at AWS. I specialize in machine learning, and I actually was prior Air Force, so working on things like this definitely has a lot of meaning towards me because those really are my friends, my family that are out in the field. And so working on Enterprise Challenge and helping you guys build these machine learning models has really been an incredible opportunity. But that said, there's definitely some pretty unique challenges with a use case like this. The first of which is working on full motion video can be really tough to keep up to with machine learning and doing inference in real time or near real time. So that was the first challenge I really had to tackle, is how are we going to detect objects at a quick enough speed that people can make those quick decisions out in the field. The second big concern going into this was that if you ever looked at an aerial image, so looking at an airplane, imagine you flew in, right? When you flew into Vegas and you looked out of your airplane, you looked down at the cars, and someone told you to find the white truck in that scene. It's like finding a needle in a haystack, right? There are so many vehicles, so many buildings, so much noise in that image. So to be able to build a highly accurate model to detect those objects is absolutely a challenge as well. So we had to get started somewhere. So to kick things off, we actually started by using Amazon SageMaker. So this rolled out last year at reInvent of 2017. And one of the built-in SageMaker algorithms is actually object detection, which is based off of the MXNet single-shot detector model. So SSD models are popular because they're able to detect objects, which means we not only classify an object, so say this is a car, but we also tell the localization of where it is. We say there's a car, and here's where it is within the image. So that's being built into the object detection algorithms. Additionally, they can support higher frame rates, so they do better on actual video feeds. So that was sort of our first cut. So we were given about several hours of data to help build our first model. We got to tag all that data. If anyone's ever had to tag video data, it is not fun. We literally had to go through every frame and like draw a square over all of the cars. So that's how we built out our training set, though, and that was sort of the first pass. That's where tools like Mechanical Turk are really nice, so you can actually crowdsource that out to help get those tags generated by a larger group a lot more quickly than doing it yourself. But again, we only had a couple hours of video, so we were able to suffer through it. But yeah, so we were able to train the model. We got our first pass, and the model performed reasonably well. So let's actually give a video later of our first kind of cut of the model. It took us about 3 weeks to build the entire prototype, which I think is pretty impressive. With SageMaker, it's really awesome because you have the ability to spin up those GPUs on demand, right? So we didn't have to go out, buy GPUs, install GPUs, configure them. I mean, it was just I hopped into my account and started prototyping immediately. So that's really some of the powerful tools of both the cloud and SageMaker, being able to do that whole GPU on demand type thing. So SageMaker worked great, very excited. I was like, all right, guys, I got you this cool model, let's go. And now we've thrown a wrench in the plans because now we have to run this on the edge with no connectivity back to the cloud. So all those really awesome deploy features of SageMaker are all cloud native. Unfortunately, we can't do things like auto scaling and endpoint variants on our edge devices today. So we had to sort of go back and rethink how we were going to architect this solution. So of course, we're going to use Snowball edges for our new architecture. And this week, we actually released the GPU-enabled Snowball edges, which is going to be, I think, the optimal solution. Again, there's a real challenge in trying to do inference in near real time on video data. So GPUs actually do help with the inference times to be able to help you complete inference more quickly so that you don't have this kind of clippy output of your model. So here this is actually talking about the EC2 M4 4XL, but as of this week, I'm using the GPU one. So that's going to be what we'll put into our architecture for this next generation of Enterprise Challenge. And this is actually a little outline of it. So this is sort of the, we're heads out of how we're going to think about this. So what we're going to do is actually use the cloud for training all of our models. So video data sets, definitely very GPU intensive for training. So we're going to be using the cloud to actually take advantage of our P3 instance types to train the model itself. We're planning to use SageMaker, but we also recognize that deploying to the edge comes with some nuances. So if we need to export our model out of the cloud, we might end up having to lean on deep learning AMI instead. What's nice is that because SageMaker supports Jupyter notebooks and we can run Anaconda on our deep learning AMI, it's not a reworking to do either one. So we're going to start in SageMaker and then default to what we need to do to get it to the edge. So we're actually going to take our model, build it, and then we'll deploy that out to the edge. The edge device we plan to use is going to be the GPU-enabled Snowball Edge devices. So those have the Tesla V100 GPUs on board, so that's really awesome. In fact, we might be able to get away with doing some light retraining in the field, which would be really cool too. So we'll definitely be testing that out as well. So while we're out in the field then, we're going to have a video feed coming down from Elemental. So that's going to be the H.265 encoded video. And that's going to be streaming directly onto the Snowball Edge device. We will be doing inference and detecting objects in those video feed in real time out in the field. And then we'll actually have a nice user interface so that analysts can go ahead and see objects being detected, track metrics. If we can get really fancy with it, I'd like to have where we can have the analysts go back and say, okay, when did you last see the white truck? Show me all the scenes with the white trucks in it to help kind of prove out, well, the fidelity of our model and also a real world scenario, right? So before we can make decisions, we need to understand the history of what led up to that moment, right? So this is where we're thinking right now with our notional architecture for how we're going to integrate AI into that whole field aspect for Enterprise Challenge this year. And here it is. Yep, so here's a cute little video. So this is actually our prototype that we built. Again, this is trained on about 3 hours of video data. So that's why you're going to see the boxes kind of coming in and out. But what's really cool is that this was running on a live video feed. So we actually had the plane flying around. It was streaming a video feed down, and we were passing it through this model and being able to watch it out in the field in real time. So we definitely have gotten, I think, a good start of prototyping and really testing all of this out. And I definitely need to put a plug in here too with for Elemental for sure, and the importance of having high quality video. With machine learning, you know, high quality data dictates a high quality model, right? So you can't really put in bad data and expect to get a great model out. So whenever we're doing things like looking for certain targets, we're looking for the raft in the ocean, we're looking for the white truck, we need to be able to see that in the video that we can tag it. So you need a high quality video to actually see that, especially from aerial imaging where you're looking very far away. So this is sort of the initial cut of our prototype, so hopefully next year we'll have an even more awesome model. And a quick plug too, so I'm going to go really deep into this architecture actually later today, AIM 334. So we'll actually be diving into the code and the actual infrastructure and architecture that built this specific model to get a much deeper look into that. So aside from my session, we also have a whole collection of awesome Elemental sessions. So here's the ones coming up. I want to make a quick call out to CTD202. So that one's going to be at 11:30, and that's going to be a deep dive into Enterprise Challenge and how we had set up the architecture for that. So it's going to be kind of the same talk, but at the 400 level. So we're going to go much deeper into kind of technology behind what powered the demonstrations that you guys saw here. And I believe that's all I have. So we have about 10 minutes for questions if we want to take any questions.
Would you grab a seat?
All right. Put this down.
If not, I got a question.
That's scaring me.
Use this to get a, here we go. Use this. Go ahead.
How much latency was experienced at the edge? I mean, from the time the image hit the lens of the camera to when it showed up on the screen at the analysts, what was that total latency end to end?
So the latency using Unicast was I almost said 1 minute, 1 second, when we went with the ABR. Now remember, that was not going to an analyst workstation, because until now, there are no analyst workstations that have been able to handle ABR. They're designing to that now. But to get to the screen, it was anywhere from 5 seconds to all the way to 12 seconds, and it depended on what you did with the ABR. You want to cover that more in depth?
Yeah, if we put the ABR just on a high-speed origin server and served it directly, so it came off the aircraft and we pushed it right to an origin server, we could get that to, an analyst could pull that within about 5 to 7 seconds, depending on where you were on the eastern seaboard. And then when we went one step further with the repackaging for the media package service, that provided the in-the-cloud DVR capability, so you could slide back and forth, do some trick play. Actually offers now a 14-day window to do kind of a network DVR. That increased the latency to between 9 and 12 seconds. This year we are going to try some new things, so there's been some evolvement of ABR technology even since last year. And we think that we're going to get those latency numbers down even lower. So ultimately that 1 second multicast, unicast was our best case, and then the 5 to 7 seconds for ABR, and then ABR with DVR was about 10 to 12 seconds.
Yeah, and it is getting better. So it started out with 30-second delay, and then they did some changes. You guys are working on a cool technology. I don't understand it. I was a stupid aero major, so I can tell you if it flies, but that's about it. And you start sending the packets even before they're written.
Not quite. So we demonstrated a lot of use case with HLS and Dash streaming last year. This year we're going to be kind of focused more in on the CMAF technology, the Common Media Application Format. And that allows you to basically take a chunk or a segment of video, say it's a 1 second or 2 second segment, and almost kind of break that apart into smaller segments and then send those out. Now, you're updating the manifest a lot quicker, so now the client can start to decode before the full segment has really came in. So that's how we think we're going to get the latency down a little bit further.
Yeah.
So you're using HLS technology?
Yeah, and next year we're going to be looking at chunk transfer encoding. Yeah.
Okay.
That's it. That's the name of it. I just love the name, chunk transfer. And that also highlights a bit the two different, we have time dominant and then we have content dominant. Time dominant, think of the actual operators that are flying the vehicle. We might end up just sticking with unicast for that for a while. Yeah.
So yeah, for a little while we'll probably have almost a hybrid approach where this time dominant sense will still pretty much consume this unicast traffic. The fact is it does work through the cloud just fine. And then the content dominant, where you want things really richly defined, or you want to add AI, or you want this trick play capability, and the time isn't such a sensitive component, then we can be this content dominant factory and basically produce that content and curate it for web streaming.
Sir?
Question?
So kind of a complex question. These microbursts, obviously they're designed for military applications, and they need to be secure, they need to be have the same failures you have in the cloud. How do you protect these, what are they called, the snowball edge units, from being compromised by malicious actors? Is there some sort of consensus model between several snowballs? Is there a single point of failure? How do you make sure that this machine learning model isn't lying to you by one compromised box or one compromised line of code on one box? Because if they're physical, unlike with the Amazon, cloud infrastructure platforms, you have restricted access. You can't physically get to it. But technically, these things are physical. They exist in the real world. You can access them if you're a malicious actor. Therefore, if you have physical access to a box, you can own it. How do we shield against that in this scenario?
Same way we're doing it right now as we speak in theater and in training. So this mesh network, it does operate. You can bring it up to the TS level, at the secret level, add-on class, hardened. And whenever you have a server or device that's classified for whatever reasons, whether it's a content that's on there or you got a stamp says secret on that box, it is treated under the same protocol that we do today. So it's going to be exactly the way we're doing business.
Is there, I guess, to segue, is there some sort of consensus model? Is there more than one edge unit that says, hey, you know, we have, I don't know, 3 edge units, and these 2 guys are saying one thing, and this guy's saying completely something else. Maybe we should, I'm thinking kind of like from a blockchain approach, how you would take care of blockchain technologies in this case. Does that technology exist? Is that in this model? Is that thrown away, or am I approaching stuff that we can't really talk about?
So that goes more into the machine learning, the algorithms that y'all are running, Kate, it sounds like.
So the models themselves, the goal is to actually be pushing those and controlling them all through Greengrass. So they'll be accessible through the cloud onto the edge, but not necessarily editable on the edge itself, but it'll run in a container. As for having 3 separate models for consensus, I don't know if we've thought about that just yet on how we're going to tackle that. I think that's smart even just from being able to produce better results. So if we have multiple models giving consensus, that should be able to help increase our confidence overall. But I don't know if we've really thought too deep yet on how we're going to prototype that out, to be honest. So
that might be the first thing we break.
Probably the first thing we break, yeah.
Thanks,
But no, definitely a great point.
Yes, sir.
Blue forest and red forest tracking stuff that's out there. Have you guys thought about either feeding that into the models as seed data so that it's better at recognizing things we already think we know where they are, or alternatively taking the model output and feeding it into those systems as automatically tracking either unknowns or known blues or reds on the maps?
Yeah. I like the way you're thinking. What we want to do is try to get as much data into this to feed the model. That's a perfect intel device, if you will. Friendly force position needs to come in there. You don't want to be attacking your own gals and guys, right? So we're looking at other sensors to possibly bring in for this EC. By the way, that's news to you. Mazint, maybe, whatever else we can get our hands on, and start working the big data issue. Which is why I was real excited to come here and see what they're doing with the new Snowball Edge, because with the now increased size and compute power, we can start dreaming bigger dreams and bringing in that kind of data, because, yeah, we don't want to drop any data on the floor. Sure. Good thought. Thank you.
Yeah, and from the machine learning side of it, I mean, it's absolutely going to end up ultimately being multiple models. So we'll have one model probably doing object detection, but we'll have another model that's looking at that kind of data and also kind of infusing those to create that final ConOp picture. I mean, absolutely.
So probably one more question. Is that why you're dimming the lights, to tell me that we're almost done? I got it right down here. Yeah, 2 minutes and 42 seconds.
As far as getting more data and running more models, how much data, how many feeds, and how many models can one Snowball Edge unit run? Or do you need multiple to support a single mission?
He's sounding like me. I'm asking all these questions because people are coming at us going, hey, we want to host this capability and that one, which is great. It's a great problem to have, but how much can we fit on these Snowball Edge devices effectively? And the other question is, where do you put them to make sense?
Right.
If you lose a node, you know, I don't know.
So there's some interesting possibilities there. I have not had the opportunity to test out the new GPU one just yet with this particular model. Some models require more power for inference than others. Most models are very lightweight, actually, on inference. So if we're just looking at things like sensor data, which is basically just numbers coming in, we can fit a lot of those onto one device. But for the video feeds, that is pretty compute intensive, memory intensive in particular. So that'll probably be one dedicated Snowball. So I would guess at least 2 to start. What's cool though is that we can actually do clustering with the Snowballs, even if they are the new GPU and CPU and storage, different flavors there. So cluster generally will have 5, and then it'll actually cluster the storage underneath so that we can kind of have like a simulated S3 where we have redundancy in there. So I would like to deploy something like that out in the field, because that should give us a lot of power to do a lot of fusion with all the sensors. So.
Beauty. Thank you. And they are dimming the lights, or I need to have some lunch. So can I thank everybody?
Yes, thank you guys.
And Kate, Matt, thanks for all of your help and partnership with AWS.